Well, hello everyone. This is SIG scheduling meeting, 21st August. We have a lot of interesting things in the agenda. Does anyone wants to propose anything more into that or change the order of the discussion?
I think one thing that would be useful to get like synchronous time on is like where the discussion on like workload and reservation is. Specifically, I saw there was like a very long thread in the document of considering like one as a subset of each other versus two disjoint things, and I couldn't really follow like where that conversation ended up. So if we could kind of like have a summary for that at some point in this meeting, that'd be really helpful.
Okay, so regarding so the main, I think, document that we will try to build while working on our scheduling is the one in which we have use cases tab. So currently there are not a lot of tabs. There is some introduction of the workload aware concept. Um, there are use cases. There is some early proposal of the architecture. But the next thing that we are working on, and we need to agree first within leads, is about having some more concrete proposal how workloads relates to reservations and how things could work together. That's why we thought that working on use cases and collecting them without yet having any specific proposal has value. So that's why we try to start with that. But you should expect to have some proposal from our side how, in fact, we could implement worker aware scheduling. What is currently happening, there is also a lot of discussion about gang scheduling and how it relates to workload scheduling. So this is a very good question. We are trying to answer it. Answer partially by workload aware proposal, and it should become more clear how one relates to another. I believe that gang scheduling API should become one of the workload scheduling constraints. So the ones that determine how workload will eventually look like, but people can have workloads without any gangs in it. So it's not one-to-one relation. So that's the brief, I think, description where we are.
Got it. So what I'm understanding from that is we're trying to figure out if we want to separate the two concepts or make one a subset of each other by looking at use cases. That makes sense to me. Thank you.
Right. So the distinction between the two is not clear. So there's a lot of overlap. We have some proposal how things can be different. It will be important to see whether the use cases that we think that are important or in scope map to the specific solutions that are proposed. I think this is something that everyone is interested. Okay, so regarding the use cases themselves, so we tried to come up with a list of use cases. We had input from some people to add some specific ones. I saw your Emmy comments about especially external schedulers. So frankly, I was waiting for comments about priorities, that some things should be P0, P1, etc. So this is the reason we are doing that. I will probably answer in the comment, but short answer is that so the question was whether externals, whether reservations arbitrarily scheduled by external schedulers should be supported as higher priority than P2. P2 means that this is definitely in scope for workload scheduling, but not necessarily has to be a part of MVP. So maybe we can open the document as well.
Heba, I think you are muted if you are saying anything.
I'm not saying anything.
But Heba is.
About now?
Oh, okay, sorry.
How about now? Okay. Sorry to interrupt you. I have just a question before starting going through the use cases. I'm a little bit confused. What is the scope for our proposal here and work group node life cycle? Because they are working on defining eviction APIs and other APIs. Are we going to work with them? Are we going to, if you can please define the relationship between SIG scheduling and this work group?
Yes. We definitely want to work with them. So eviction is one of the most important parts of workload scheduling. We had things a few times in the past, and I think we brought up this topic with them. However, there was no too much interactions in the meantime for various reasons. So we are now in a position that we more or less understand how workloads could be scheduled, rescheduled. It's less clear how eviction and preemption will work. I'm trying to build some concept how I imagine it to work, and then confront it with whatever was proposed there. But definitely, this is the part that should converge into one solution. So my last 2 weeks were coming back to the topic. I had a longer leave, so I had to focus on the most important stuff. So in the following weeks, I should have more time to read what was happening around. All right. So yes, regarding the use cases, on the Asia meeting, SIG scheduling meeting, we tried to go through all the use cases that we have and describe a little bit what they mean. We probably don't have time to do the same today. So I would propose to maybe to let you ask questions, whether something is unclear or whether you think that something is missing or with incorrect priority. I can definitely start with answering at least briefly any comment about reserving arbitrary set of resources scheduled by external scheduler, which mean, for instance, currently a queue for Kube scheduler is one of the external schedulers. So the good question is how important versus, of course, the other use cases this one is, because we either can, as a workload, our focus on building ability to schedule workloads by some native scheduler and build some framework around it, especially work on a common scheduling constraints that will be used by many different workload schedulers that will exist in the future. But the fact is that we have already plenty external workload schedulers already. And we believe that our priority should be to first support well those external schedulers. So I'm eager to agree that this use case should have higher priority, so that we first should accept and try to converge the existing implementations to better integrate with kubescheduler, and then build, potentially expand kubescheduler capabilities to schedule workloads. So I'm eager to agree that it should have a higher priority. So please upvote the comment, or it would be also useful to give also any real life examples are available.
Yeah, that was I can't find the raising hand button on my, because I'm on like the Zoom web instead of the app. But I was about to say what you're about to say, the second point you made, which is having like people that are already using Q like leverage the changes in the Cube scheduler, so that way we can give like live feedback faster.
Yes.
Yeah, so
Yes,
that's just
and we
wanna add to that.
definitely want to bring added value as soon as possible to existing schedulers, especially by focusing on making kubescheduler workload aware. So not necessarily being able to be the best workload scheduler, but to understand that that this is a workload. So far we reached the point that we implemented nominated no name feature, which allows external schedulers to suggest kubescheduler what should be the placement of pods, which probably belong to a workload, and kubescheduler should consume this suggestion as long as the suggestion is correct. It will use in pod scheduling. So this is what we did in the short term in the last release cycle, but this is only the first implementation. The reservations will probably look a little bit different than that. Okay, so does anyone has comments about use cases, whether they are unclear, or you can definitely leave comments.
I'm a little bit interested to know how if we need to add a separate use case for differentiation between having a whole external scheduler versus having plugins, and like how what if we have like the three use cases together: external scheduler, a couple of plugins enabled, plus the default scheduler as well. Are we going to just like how can we go through it, or work toward it? Is it like just not, like notify the default scheduler that there is another scheduler here, or we will have like a separate API or a defined API that will apply for all of them? If we can just go a little bit deeper related to this use case, and what is the scope for this use case?
Mm-hmm. Right. So I think the main API between different schedulers should be reservation API. So and the reservation API has two flavors. One is a request to default scheduler to schedule reservation, and if we have external scheduler, then external scheduler can schedule a reservation, and default scheduler can verify it and accept it. And how exactly this reservation API will look like is something that we want to have in a proposal.
Are we going to support external scheduler that not using these new APIs?
So this is not using these APIs. So I mentioned about the two flavors of this API.
Yeah.
So definitely there should be schedulers that do scheduling and still wants to reserve resources. So this is something that should be supported, but we still need to have some language between those. And what I'm mainly thinking of is to use, to give you an example, resource claims to express, on one hand, the resource demand of a reservation, but also resource claims can express allocation of resources. So it can be used in both on both levels. If you provide a resource claim which is not pre-allocated or without any scheduling performed yet, it would have to be handled by some default scheduler. But if you already have workload scheduler, you could suggest what should be the allocation of those resource claims, and default scheduler should be able to accept it as long as it's correct. So there are no conflicts with others, etc. If there is a conflict, then most likely default scheduler would either propose a different placement than the one that was initially proposed. So the component that was triggering the initial proposal will see the difference and can accept it or withdraw it. So that's more or less how I'm thinking about this API. I can mention also that the distinction between reservation and workload, in my opinion, is that workload is something that is executable. So you start workload and stop workload, while reservation is just resources that may be needed by a workload. So in some situations, we can think about workload as it is a reservation plus this executable layer on top of the resources. But reservations may be more generic and wider, broader than just what workload needs. In particular, you could have few workloads running at the same time inside one reservation. And maybe one more word about preemption, since we started. So preemption needs to both preempt reservations as resources and workloads which are using those resources. So the preemption needs to work on those two levels. So it matters whether preemption needs to preempt unused reservation or a reservation that is already used by some workload. I think this is the quite important element of the picture. So we are trying to write things down and present what I'm talking about.
I think Ilya has his hand raised.
Yes, I have a quick clarification question. Can you hear me?
Yes.
So that's not the question, it's just me asking. So when we're talking about workload, it would be really helpful to disambiguate what precisely do we mean. In Kubernetes classical sense, workload or unit of scheduling is a pod. Essentially, when we admitting something and when we're scheduling, we go in pod by pod basis.
Mm-hmm.
In external third-party scheduling frameworks like Q, that could be different. In other words, workload is something as aggregation or collection of pods, which puts a slight different twist on reservation as a whole. In other words, you're reserving resources not just for single pod, but also for collection of pods. And it's also implies how the preemption should work. But what more important is in the classical scheduling, you consider pod by pod basis and you make evaluation whether it requires preemption or scoring or assigning priority to given pod, which should be scheduled at the pod by pod basis, and you move on to the next pod. I think it'll be helpful to understand how that would work for collection of pods, or what the semantics or specific changes needs to be happening in the schedule to consider a group of pods as a schedulable unit.
Mm-hmm. Sure. So yes, the workload will be similar how Q defines it. So it may be a set of pods which should be treated as one not only schedulable unit, but also one executable unit. So you start workload and stop workload as a unit. You don't want to start half of the scheduled workload because another half failed to bind or things like that. Also, if we talk about preemption on workload level, then definitely whenever two workloads conflict with each other, and one of them in some sense has a higher priority, the lower priority workload needs to reschedule. It needs to either find alternative placement for itself, if it's capable of course, or if it's not able, then it will have to be shut down as a unit. So all pods that are part of this preempted workload will have to be shut down. One interesting thing we are like trying to describe is that rescheduling is a little bit different. We want to decouple rescheduling from preemption. So if we talk about just reservations, we can with a zero cost remodel all the reservations to be placed differently, because we need to make a space for a new high priority workload without touching the running workloads yet. And once all the reservations have rescheduled due to changed cluster state, and some component orchestrating it, for instance, Q, decides, okay, this is what I wanted. It can bring this plan into life and start the preemption process, but only after all reschedules have happened before. This way we can make sure that workloads that need to be moved somewhere else will find it's their new place and move safely there without disruption, or they have to be stopped because they could not find a better place for themselves. That's more or less how we think about preemption and how it is decoupled from rescheduling of reservations.
In my view, it would be really helpful to understand, specifically from perspective, not necessarily as a preemption or eviction, but rather than what is the atomic unit of scheduling. Because in the pod world, pod scheduling as a unit of scheduling, anonymity of a pod, it's simple. You either find place for this pod, whether it requires preemption of other pods, or you throw it away or retry it and go to the back of queue and you move to next pod. It's going to be very interesting to see how it will work on a group of pods, because atomicity now applies to not just one pod, it applies to collection of pods. Yes. And while one rule can apply to pod, you can easily assert that, it may not so easily assert to a group of pods, because situation underneath an environment could drastically change as you move from one pod to another within that group. So while you expect that you could have scheduled this workload and hypothetically you preempted a bunch of other workloads, just to realize that, oh yeah, I got to this last pod in my group and I cannot schedule it anymore because things have changed.
So this preemption could, on the workload level, could be implemented on few different levels as well. So the most basic workload level preemption is whenever we preempt a pod that is a part of a workload, and this workload without this pod cannot exist and cannot move anywhere else. The most important function, feature is that the whole workload needs to disappear, and the space that is will be freed by this workload could be used by a new workload in the first place without affecting any other additional second workload. So this is the minimum that workload level scheduling preemption should assure. We of course want to avoid the situation when we preempt one pod from 10 different workloads, and in fact we break all of them. So if we need to break one of them, then let's try to use all the resources that this workload will may free up. So this is one thing. The second thing is how to select the best workload to preempt to have the minimum bad impact. So this requires some higher level logic and calculates the cost of preempting certain workloads based on how advanced they are, how many resources it could we could reclaim from them. So that's more advanced logic will be needed, including simulation of what will happen if we stop this workload first and another workload, and so on. So there will be probably discussion about simulation API that not only consider one operation on workload, but simulate several different scenarios affecting multiple workloads. And this is what highest level schedulers, like we think about them as orchestrators, could do, because they have a picture of many different workloads which are waiting. They have a picture of workloads which are running and have a much better understanding what is the real value of and cost of preempting them.
I have another comment, but I don't want to monopolize the meeting. If somebody else have questions, please. Okay, then I'll ask it. So
Okay.
with the other schedulers, and again, specifically going to be talking about Q, because that's the one I'm most familiar with, they essentially make high-level decisions for workload, yet they rely on the actual scheduling on Kubernetes scheduler, right? So they make the best assurances that have enough capacity and eviction of previous workloads, but then they say, okay, now as we're going to actual mechanics of pod scheduling, this is where Kubernetes scheduler kicks in. And it's important aspect because it doesn't mean that those two schedules operate in parallel. There's rather a dependency chain. Okay, first do workload scheduling and then delegate the rest to Kubernetes scheduler. So it's kind of one before another. Are we considering the same model of operations for all external schedules where ultimately they will all defer final decision to Kubernetes scheduler? Or do we see external schedulers actually making decisions themselves and assigning pods to nodes?
So one of, at least my opinion about that is that we may have 3 different levels of schedulers. But this is something that there are many people which disagree with me. So I don't want to like present it as SIG scheduling opinion about that. But I imagine that we could have 3 different levels. The level where we have orchestrators, which basically take care, like look into several different workloads and first of all try to start or coordinate their execution to achieve the best use of resources that are available, but not necessarily do workload scheduling. The middle level could be workload schedulers, which know how to schedule workload based on workload scheduling criteria or constraints. So each workload have some set of requirements. What kind of placement works best for it? And we could have many different implementations of workload schedulers, those which are better, which are worse, but the input, the interface would be the same for all of them. It would be officially supported scheduling constraints. And we may have many different algorithms finding a placement. And orchestrators could use those workload schedulers to find a placement, but orchestrator can see this wider picture of many different workloads, so can do some simulations, but not necessarily do scheduling. And the lowest level might be the pods level scheduler, which is currently Kube scheduler. And Kube scheduler may receive the input from workload scheduler, which will tell it, okay, this is a workload, this is a set of pods that belong to this workload, and this is the proposed placement. And as long as the placement does not conflict with others, it will be accepted. If it conflicts with others, it will trigger the rescheduling of the affected ones, unless the plan that kubescheduler received already have a plan for many different workloads, new placements. If this placement proposed is correct, then kubescheduler can accept it. And once the new placement of many reservations is accepted, kubescheduler may start executing it. So starting pod migrations into new places, and to give up space for a new workload. So this is a picture that I have in mind, but this is not necessarily so. So the question whether the workload scheduling should be a part of queue, the answer, my personal answer, is that at the beginning, of course, yes, because this is what we have today. But it would be interesting to move workload scheduling capabilities into a separate component, which would be replaceable, which will have well-defined interface, and this is the ultimate situation that I think would make sense. But all that I said, we are trying to describe. So you will have a chance to comment in the document, not just during this meeting.
Makes sense. Thank you. Yeah, I agree. Having centralized or some kind of focal point for workload definition and scheduling will be super helpful, especially as we're opening up to possibility to use different external schedulers, which again, they may have certain expectations, like queue scheduler or queue itself is fairly opinionated. They assume that essentially queue is the only player in the sandbox and everything else can delegate it to the Kubernetes schedule. For example, you can run queue or multiple instances of a queue in a cluster, and that puts really interesting use case scenarios where schedules start competing with each other, specifically when they deal with resource reservations. Because again, for example, queue does not understand today the resource quarter. It doesn't consider that as a construct altogether. So it implies that it has its own quarter tracking. So any external entity which participate in that or consume quarter may adversely impact queue, for example. So it's nice to have some kind of centralized or focal point where ultimate decision is taking place. And I'm super excited about this effort, what you're doing with the workload definition, and can't wait to see it. Thank you.
Yeah, I second area actually suggestion, and I would love if we can have under the reservation a separate use case or like sub use case for the external schedulers, and try to just put as much as we can. Like from the use cases that we heard about, specifically from Q, from Volcano, from other external like famous or like well-known or established schedulers, and see how can we make them work together without this, like with the minimum disruption.
Right. I can only say that we definitely need your help in understanding use cases, because we have some picture. I mainly have knowledge how Q works, but I'm less familiar with others. So whenever you put some new use case or a comment, I can read more about that, dig in.
I have one more question, if you don't mind. Do we have use case for time-bounded schedule reservation? So, for example, like basically jobs, I believe, or batches. Is this like do we need to have like a specific or separate use case for the time-bounded?
So we have it in the document. It's listed there, but the comment is that it's we are not going to support it in the nearest future.
Oh, okay.
So if you have any opinion about that, please comment on that.
Okay. I might because this is like an essential workload for many real use cases, like like the ML training and like data processing, and it's too much workload related to ML. Really, like rely on this type of workload. So I might need to just add a couple of use cases, and we can start discussion related to that.
Definitely, yes, please do.
Yeah, I guess I'm curious just on what you mean by the time-based, but I guess if you add it to the doc, I'll take a look at what you mean.
Sure.
Right. In the doc, there are no much details, but feel free to enrich it with more specific use cases and so on. Okay.
And I guess something I did want to ask. So like it feels like the topology-aware scheduling is more of like the area we talk about for queue. And then like in this world, like let's say we have workload-aware scheduling, we would still delegate to queue for the queuing aspect of this, and then scheduling would be separate. Is that kind of the envision here? Because like I know queue kind of, well, with topology-aware scheduling, it does both, but
right. Currently, queue is both orchestrator and workload scheduler. We have to accept this fact and support queue the best we can, but I think it definitely could be split into two separate elements, and the challenge would be how to define API between those elements.
yeah, and the topology-aware scheduling is still alpha in queue though, but like the main use case of queue, at least we still rely on the cube scheduler for placing pods from queue, and that works fine with us. But okay. I guess like that's the only thing. Like it sounds like we're queuing, queue, scheduling, which is kind of the core idea of queue in the beginning, was to not reinvent the wheel, right? But with Taz, we sort of did that.
Okay, we have more items. I'm sorry, I haven't paid much attention to how the time flies. Okay, can we move to the second topic now?
Yeah, thanks. So I'll try to be quick just to share the main points. So me and Ricardo, we have took a slightly different approach in tackling the workload-aware scheduling, and instead of focusing on high-level use cases and so on, we try to find a place that can be actually easily implemented. So we are currently focusing on two problems. The first one is to provide coordination of multiple schedulers running over the same cluster. Actually, you have mentioned a lot of topics and questions related to this. And the other problem is to actually provide some kind of a gating for getting scheduling. So I just talk a bit about the first case and then the other one. So like we are trying to build a kind of coordinator, a new API type, which each scheduler is then expected to create. So instead of binding directly to API server, each scheduler is expected to create we call it a placement proposal, which is a list of pod to node assignments. And then we have this controller, which is consuming all these placement requests and is kind of doing this coordination or an arbiter, saying which placement request will get processed next, which creates this kind of a fairness among schedulers. So one scheduler doesn't unnecessarily stamp on another one. So that's one how we want to solve it. And there's also a validation. So every placement request is validated. So we can still respect the cluster-wide topology constraints or different constraints. And the other problem we are trying to solve the gating for the gang scheduling. So each of these placement requests can be either so in case there are two or more pod to node assignments, this controller can say that either all of these assignments will be bound to nodes atomically or not. Well, this feature, this multi-binding feature, is still not implemented on the Kube API server side, but it would be quite a nice feature to have. And basically, if why there's this gang scheduling mentioned, well, if you, for example, run a gang scheduler like a Volcano, then you can produce a placement request with two or more pod-to-node assignments, which is kind of this what a gang scheduling is. And then this controller can do this multi-binding operation atomically. And so either all of these node assignments will get bound or not. And because we have this validation, then we can validate that any list of node assignments is either complying with the cluster scheduling constraints or not. So like the main reason why we are discussing this today is to just to share our proposal and open a discussion on this topic. And as I've heard for the last 40 minutes, there's a lot of topics and questions that are actually intersect with what we are proposing. So if we have time, it will be I would like to ask you to go through the proposal to see if it is something that would be something that you like or like to explore. Mm-hmm. And we have also prepared a demo. So Ricardo created a public repository. So right now we call it the current solution combiner. And so the idea is that, well, there's a demo and there are some steps that you can go through to install it. So right now it's an opinionated implementation. It can change. Nothing is set in stone, but the main idea of the demo is to actually demonstrate what we mean in the proposal. And there's also this video. And yeah, I guess that's all what I wanted to share. So unless Ricardo has other points to mention, that thank you for your attention.
I can add one thing, because I'm a bit surprised that you are saying that your proposal is different, because from what I heard, it's more or less the same how kubescheduler currently works, at least how we want it to work. So kubescheduler can accept placement proposal in form of pod to node assignments. This is the nominated node name feature that we have implemented last cycle. And this should serve exactly the same purpose. And regarding the atomic binding, that would be a proposal for a workload level scheduler binding process. to make binding workload aware and gang aware. So that's definitely interesting for us to hear how Hugh approached that topic, but I don't feel it's different. I don't feel it's much different.
Okay. Yeah, I haven't read everything there is to know, so it is likely that some parts of the proposal are already implemented. And when we are reading that workload aware scheduling proposal, because of we didn't see like any implementation details, we tried to fill it in. So that's why we produce this proposal. But actually, it's a good thing to hear. So if there is more in our proposal that is already implemented or even part of the workload aware scheduling proposal, that's even better. So that's actually another reason why me and Ricardo wanted to sync with you, Dominic, so we can actually identify what is in common if we understood those concepts well and actually how much we are aligned. So yeah, so like would also like to sing maybe on the Slack and just discuss the details. So if you have some time, that would be great.
Okay, yeah. So do you want to show quickly the demo?
Yeah. If you could just play the video, is there the third link?
Sorry, can you say again?
Oh,
Open.
yeah. If I could ask you to play the third link, there's a link to the video. Yeah, third.
Okay, this one.
And I would probably ask Ricardo here if he could just guide you through the individual steps.
Yeah, sure. Hope it is not too fast. But we just play it. We're gonna see.
Okay, so shall I start?
Yeah, go ahead. So yeah, there is the process of actually deploying the application here. So that's pretty straightforward and fast. So we just build the image and get it loaded inside this kind cluster, so we can get the pods running. We have one pod for the scheduler, another one for the controller. So the idea is that the scheduler will send the placement request to the controller, and the controller will resolve if it is valid or not and return back. So after deploying, you can see that we should have two pods there. So as I said, the scheduler is going to communicate with the controller. Then there is an example of how to get this. Get a deployment pointing to the scheduler. So yeah, that's pretty straightforward as well. So as soon as we create this deployment, yeah, let's wait a little bit. There we go. So yeah, it's going to create that. And then you can see that there will be all the pods as expected. And at the same time, we also going to have 10 placement requests. The name of the placement request is the UID of the pod. So inside each placement request, we can see if it was success or failure. In this case, how they are all success. So as you can see on the status of the placement request, we have multiple bindings as we have on the spec. So we may have a different number of bindings that we want. And then the rest is just house cleaning, I guess. We just delete the deployment, the pods go away, the placement request also goes away, and then you install. This is more like a working proof of concept of what we think or how we think that this could work.
Mm-hmm. Yeah, very good. I think this is definitely aligned with what workload aware scheduling should bring. So one of the main main elements that that it brings is that workload is started as a unit. So you have to make sure that the binding is not only atomic, but also, so we are thinking about making it multi-stage process. And whenever one of the stages fails for one of the pods, the whole workload needs to return to the scheduling phase, because the workload may no longer be well placed if the binding was not successful. So we definitely are thinking about similar thing, and the proposal is definitely aligned with what we think should be in the workload that we're scheduling. So feel free to take part into this this effort. We can learn from your proposal, reuse. The last thing I can mention is this is the distinction between gang scheduling and workload atomic binding. Both are related, but binding, atomic binding works for all kind of workloads, while gang scheduling only for those which require have some specific placements. So both things are needed. Even if you have the best placement made by the best workload scheduler and your binding fails, you don't want to end up with binded it halfway. Okay.
Yeah, I think we have Ilya. I think he has his hand up.
Oh, yeah, I had just a quick comment. Something to echo what Dominic just said earlier. For demos like this, it's super helpful to see examples when scheduling is not successful, specifically when binding did not work for one or more pods. Because in this case, when we saw this demo, it's almost indistinguishable from regular scheduling. So just that comment, that's it.
Right, and what we are in fact missing is the mechanism how to get back to the scheduling phase. This is the mechanism which is completely missing currently.
Well, I'm not sure if it's missing, but at least it's not visible in demo.
I mean missing in the standard Kubernetes.
Oh, got it.
Do you think that it would make sense to actually start proposing that multi-binding right now?
So I would suggest to wait for workload hour scheduling proposal, which will describe the similar idea. Well, but it's of course up to you. You can do it earlier. Actually, works. That doesn't really matter because whatever idea is works good. We can reuse it, but we are in the middle of describing it. It's a matter of polishing the document and agreeing on what should be the content. So that should be definitely a place for discussing the details.
Right.
We are over time already. So I think we have to wrap up, but definitely feel free to put whatever items to the agenda you want to discuss the next meeting, and we will continue. So thank you for interesting discussion, and yeah, see you all next time.